Hello everyone, thank you for joining us for today's webinar. We have a lot to go over, so let's go ahead and get started. So today we're going to talk about decoding the exida certificate, some new things that we brought forth for the certificate in 2017. My name is Loren Stewart. I am a CFSE. I work here at exida, focusing mostly on our mechanical customers. I work with helping our mechanical customers pass SIL certification, along with doing FMEDAs and doing research on failure rates and stiction and the 2H initiative. I like to say no matter where you are or where your customers are, we have someone close by to help with any of your functional safety needs, whether that's in functional safety, alarm management, or cybersecurity. exida is involved in the complete supply chain in functional safety in multiple different industry sectors. We start the whole way from OEMs and original equipment manufacturers, the whole way through the people who use their products and end users. We have software tools and trainings, consulting, procedures, templates, everything related to functional safety, security, and reliability. We have engineering consulting services in functional or process safety, alarm management, and cybersecurity. We have a bunch of engineering tools that will help you save time and money while increasing efficiency and productivity. So if you're working on PHAs or LOPAs, SIL selection, SIL verification, SRS creation, proof test procedures, alarm rationalizations, cyber risk assessment, we have tools to help you accomplish your goals. We also have certification. If you're here for this webinar, you probably know a little bit about exida certification. Today's webinar is going to really focus on the IEC 61508 certification and that template, but we also have certification in IEC 61511, ISO 26262, cybersecurity, machine safety, and personnel certification. So we'll go ahead and get started. This webinar, we're going to talk about what happens in an exida certification, how a company gets a certificate and where to find them, how one should use and interpret that exida certificate, and how the certification relates to all of the functional safety compliances. To understand those topics, that subject, we're going to break it up into mini topics. We're going to start with look at what goes into that certification and all of the hard work that the manufacturers do to get that certification and why they're so proud of it. Then we're going to take the certificate itself and break it up into 4 main sections: the scope and assessment level, revision and expiration, main conformity declaration, certificate template, and the failure rates and supporting documentation sections. Then we're going to look at different examples of certificates, point out some pretty important things on those examples. We're going to talk about how to tell if a certificate is valid and what to look for on certificates to see if they have been forged, and how that certificate relates to compliance. So we'll go ahead and get started and talk about what actually happens in the exida certification process for a product. So in exida certification, we always start with a kickoff meeting. And this meeting will let both parties know exactly what is going to be needed, what documents we should look at, what procedures and are in process, if this is going to be a simple mechanical device or a single device or a family device, if it's going to be software involved, if this has been proven in the industry, or if it's a brand new product out there. So we're going to then know how to set up the certification. We then, from the documents that we collect, take a cutaway or an exploded view drawing along with a bill of materials, and we create a failure mode and diagnostic analysis of the product. And this FMEDA will be able to let you know the ways that the product was considered and what the failure rates associated with those applications are. It's broken down into safe and dangerous failure rates, and we'll talk about that more when we zoom in on that portion of the certificate. After a FMEDA is finished, we then do, if applicable, a proven in use analysis. We'll look at failures and shipments and go through all of the failures, see why they failed, if there was a root cause analysis done, all of that information, and compare it to the failure rates from the FMEDA. We then go through and do the process analysis. We'll look at all of the documents, the quality procedures, quality documents, see how everything's done on that side, how modifications are done, how returns are done. All of that information is in a process analysis. We create a safety case, which is our tool that we compare every single line and requirements of the standard to documents and procedures in place by that company and say exactly where in each document they meet each requirement of the standard. In that process, we also do an on-site audit. While we're there, we'll collect more documents if needed. We'll do a plant shop tour. We'll go through and look at their quality system. All of that while we're on site, along with doing a short training. And then finally, once the safety case is finished and all of the requirements are completed, we then hand the safety case off to a completely independent second auditor who goes through and makes sure that they agree with the initial auditor's assumptions and saying if it has passed or not. Then and only then, if both auditors have signed off on it, an assessment report and a certificate are completed once the project is finished. And that certificate is what we're really going to be looking at today. So it's only after everything has been finished and everything has passed the process. So when device manufacturers put these certificates up in their lobby and put these certificates on their website, it is a big deal for them because it has been a lot of hard work that they've gone through and able to get this certificate. It's not simply just a check in a box. It's not just an easy metrics that they were analyzed on. It was really in depth. So that's why we want to show you all of the portions of the certificate that give you all of that critical information for your plant and for your calculations. As I said, the exida certificate is broken up into 4 main sections. On the front, going from left to right, you have the gray section on the front left, continued by, that shows the scope, the assessment level, the revision, and the expiration. In the middle there, you have the main conformity declaration. This has a lot of the main portion of the front of the certificate. It has a lot of critical information on that. Then on the back, in the gray section, you have your certificate template, followed by the main section on the back where your failure rates and your supporting documentation are. So let's go ahead and start in the left-hand side of the front of the certificate and look at the scope assessment level, the revision, and the expiration date. So we'll start at the very bottom and talk about our ANSI certification. So this is something that we're very proud of. We've been accredited by ANSI, which is a part of the International Accreditation Forum. And ANSI is the United States portion of the IAF. There, if you go to different countries, they might have different certifying bodies, but the United States is ANSI. This is something that we get audited. We just finished one up not too long ago. So after they've gone through all of our process, they give us a number and say that we are certified to be a certification body. So we are accredited to go out and certify others. So this is, as I said, a big deal for us to brag about, and anything that has been set up and assessed to our scheme will have our ANSI number or logo on the certificate. We always say that no matter who you get your certificate for, make sure that that accreditation body is, or that certification body was analyzed by an accreditation body, an accreditation program. It's one thing to say that you're really good, but it's another thing for a third party to analyze and make sure that you are doing what you're living up to what you say you should be doing. In the middle of the gray is a key piece of information. This circle in the middle talks about the what it has been certified to and what it is the systematic capability. So this certification mark is actual, manufacturers can use this certification mark on their brochures or on their product itself, and all the documents per the assessment level. So in this circle, this reads that the device has been certified per IEC 61508 certification, and it is SIL 3 capable. So this product that we're looking at, for an example, would have passed Exida's IEC 61508 assessment scheme up to a SIL 3 capability level. Right under that is going to be your revision and your expiration. You'll always have the revision and a surveillance audit or a valid until date. Exida certifications are normally for 3 years. We have done 1-year certs as well, but you will always see an expiration or a surveillance audit due date on an Exida certificate. We are board of directors, which are comprised of mostly end users, said that they want us to go back every so often and make sure that the manufacturer is still doing what they said that they were doing, still following those processes. When we go back for the surveillance audit, if the surveillance audit shows that there were modifications, that they didn't follow their process, or that they're not doing what they said they would be doing, they're not documenting, their certificate will actually get withdrawn. And not only that certificate for that product, but all the certificates for the same manufacturer. So it's a big deal for these companies to pass even certification audit or surveillance audits. If you have any questions what the latest certificate is, you can always go on the Exida website, and we'll talk about the SAEL later. And you can always pull up the latest and greatest certificate and make sure that it is what you have in your hands. So next we're going to talk about the main portion on the front of the certificate, or the main conformity declaration. Starting at the very top, you have the certificate number, and this is going to be a unique identifier for each certificate. So not just for each company, but each product and certificate that they certify as well. It will always have 3 letters followed by 7 numbers, followed by the letter C, and then 3 numbers after it. Underneath the certificate number, you're going to have the product and the manufacturer. And this is going to define what was actually evaluated for this assessment. If this product is sold by multiple manufacturers, it doesn't just mean that manufacturer A has been certified. That means manufacturer B, C, and D will be as well. There could be things like different return process, different customer notification process. They might even have different ways to qualify suppliers or make modifications. So we always say if the certificate is for manufacturer A only, look to see if manufacturer B has been certified as well. Under the product and the company, you then have the standard and the assessment level. As you can see here for this example for the webinar, we're going to be talking about certificates that have been assessed past the requirements of IEC 61508. This one was the 2010 version of the standard, or the latest version of the standard, and it was assessed from parts 1 through 7. If you're very familiar with the standard, you might say, well, part 3, if I have a simple valve, part 3 is software based. What about that? Well, we still went through, we made sure that there weren't any portions of this product that could interfere with that. If there are portions that are not applicable for a product, we obviously don't consider those, but we have still taken into consideration part 3. Parts 5, 6, and 7 are informative, but they are still considered and assessed. When you talk about IEC 61508, it really is broken down into 2 main portions, which is the development process or the quality system requirements, which are known as systematic requirements, and your product-specific performance requirement, which are random, and that gets us into the block below. So first, let's take a look at what systematic capability is. And systematic capability is that quality system, those development, those procedures, those processes, that documentation. And it will depend on the SIL level, the more stringent the requirements are. So if you have a SIL 1 product, the standard has a list of requirements that need to be met. If you have a SIL 2 product, that product needed to meet all of the SIL 1 requirements, then add on the SIL 2 requirements, and so on. When you are talking about systematic capability, it is going to talk about that maximum level that you can put this device into. So if a product is a systematic capability of a SIL 3, then it can be used in SIL 3, SIL 2, SIL 1, SIL 0. But if that systematic capability is SIL 2, it cannot be used in those SIL 3 applications. It can only be used in a SIL 2 or SIL 1 or SIL 0. But just because something says it's SIL 3 capable does not mean you just take that product and you don't put in any redundancy, you don't do any testings, you don't do any calculations, you just put it in and you cannot think about it and go. No, that just means that this device had the quality built into that has enough reliability for a SIL 3 system. Under systematic capability comes your random capability. And this is going to talk about your product-specific performance requirements. Your random capability is going to be your minimum hardware fault tolerance for an element, or the tools you need to find out that minimum hardware fault tolerance for a device. And also the things that you need to calculate your probability of failure for an entire SIF. These clues in your random capability are going to be if it's a type A or type B equipment type, type A being your simple mechanical devices, and type B being your smart devices. And then how it was analyzed. There are two different types of ways to analyze the product, either route 1H, which is your safe failure fraction, or route 2H, which is actually a prior use justification of the product. Having those pieces of information, you can then use the tables in IEC 61508 and 511 to figure out what your hardware fault tolerances need to be and what equations to use to consider for your probability of failure on demand average for low demand applications, or PFH, your probability of failures per hour for high demand applications. So that random capability gives you clues on what to do your calculations with. Under your systematic and random capability box, then comes your safety function and your application restrictions. So this is going to tell you how the product was analyzed. It's saying, well, if you have a tight shut-off gate valve or a ball valve, it's going to say it needs to close in a certain amount of time, or it needs to make sure it acts in the way it was analyzed. Underneath that is going to be your application restrictions. This could be environmental limits. This could be any special requirements or restrictions on the application. A lot of the times it would be too much to list on the certificate, so most of the time the application's restrictions will say, see the product safety manual or the IOM for the most detailed analysis on how you can use this product properly. At the very bottom of the front of the certificate, you're going to see two separate signatures, and those are the two individuals we talked about earlier. You have your evaluating assessor and your certifying assessor. That first top line is going to be the one that does a lot of the hard work. They do the FMETA and get the failure rates. They do software criticality analysis if there's software involved. They're going to do the safety case with all of the requirements and see how it all lines up with the documents. Once the evaluating assessor completely agrees on it, there's no action items, it's good to go, they'll bundle it up and send it over to the certifying assessor. That certifying assessor will be completely independent and give a second review of the product, of the quality, and the safety case itself. Only when both assessors completely agree will they both sign off on it and the certificate and the job be completed. So now we've covered the front of the certificate. Let's move on to the back. On the gray area, it's going to be the certificate template. Because our certification board is constantly talking to us, we continually evolve and evaluate what's the most important information on this certificate. What's the best way to present it? How is it least confusing? So our certificates continuously change, and to know why one looked one way and one might look a different way, look at the certificate template revision, and you can see, well, okay, this was version 3 revision 1, where the last one was version 3 revision 0, or yeah, revision 0. So there might be slight changes in the template. It doesn't necessarily mean one's better than the other. It could be just what was used at that time of the certification. Now let's look at the main portion of the back, where we are going to look where the failure rates and the supporting documentation are on the certificate. In the very middle of the back is probably the most important information. You're going to have your failure rates. These failure rates are going to be listed in a table, It's listed by application. So if you have it analyzed for clean service or severe service or both, full stroke, tight shot off, open on trip application, close on trip application, with partial valve stroke testing, without partial valve stroke testing, all of that information is right in this application. Then it's also broken out into failure modes, and these failure modes, reading from left to right, are the safe detected failures, safe undetected failures, dangerous detected failures, and dangerous undetected failures. These numbers are used when you're trying to figure out your average probability of failure on demand. That PFD average number has many variables. There's actually 9 variables into the equation that can change. Many of those 9, 7 of those 9, are in the end user's hands, such as proof test interval, proof test coverage, mission time, how your maintenance capability, all of that plays a part into these calculations. So if someone's just giving you a PFD average number without listing all of the numbers and assumptions they made for that calculation, it can be very dangerous. So instead, always ask for the failure rates, both safe and dangerous, so you can do your own calculations with the numbers that you're actually going to be using in real life and not just assumptions. The dangerous failure rates are going to go into your probability of failure on demand calculations, where your safe failure rates can go into your safe failure fraction calculation if you need that, and also your mean time before safe failures or your spurious trips when you're going to shut down your plant. So knowing not only the dangerous failures but also your safe failure rate is very important as well. Well, how do you know if you get a certificate? How do you know if these failures are good failure rates or bad failure rates? You know, sometimes they can be in different places. We always say do a sanity check. StillSafeData.com is a website, and it has many different final elements with a lower bounds and an upper bounds. And I always call this my sanity check. If you say, like, let's look at the first line there. You have an actuator, spring return pneumatic piston actuator. You receive your certificate that you want to buy. You're all excited, but you notice the failure rate is 200 fits. You're like, well, is this good? Is this bad? What does this really mean? How are those failures in time actually relating to life? Well, come here, and that 200 fits. Okay, that falls nicely in the middle of the bounds. But you might notice that those bounds that's a pretty big range, 190 to 1,000. Well, that type of actuator can have a bunch of huge range of complexity. There could be many different ways of applying it. So it can be very simple, it can be very complex, it can be even the generic number is in that range. So this could be why we have such a large range. If you're at something like 200 and you fall in between, great. You know that you're using good data. It's going to be great in your calculations. Let's say you fall at 180. Well, it's a little lower than we've seen, but it still meets the sanity check. But if you receive a certificate that has 2 fits, you're going to say, is this actuator better, order of magnitude better than every single actuator that has ever been out in the market? Or is it something that might have been done with improper analysis, whether it was just looking at the returns or doing cycle testing, something like that? How did this information come about? We just say question it. Also, if you have a certificate that has 2,000 fits, that might be a little overly conservative. So this gives you that sanity check. I'm a visual person, so what does this look like? Well, we did a comparison of solenoid valve, and we said, well, are all of these really coming out to the same? So we plotted a bunch of different FMEDAs. There can be different complexities, whether it's the poppet or the spools. We compared it to Dow field failure data, which is a public study. Also a pipeline company data and ARITA, and derived data from this. But we also had some other failure rates in there. So where did those come into play with SillSafe data? Well, for a poppet valve, there's the limits, the very lowest limits for SillSafe data. Huh, that's weird. Well, what about a spools valve? Oh, that's even worse. So when you have things falling way below, orders of magnitude below that SillSafe data limit, see where those numbers are coming from and why. You don't want to use unrealistic numbers in calculations because you will not get realistic results. Under the failure rates on the bottom of the back of the certificate, going back to the certificate, you have that supporting documentation. It's going to list your assessment report and your safety manual document name or document number. The assessment report is going to be all of that extra data, what documents we looked at and what we assessed, how our assessment was created, all of the details that went into the overall certification of this product. The assessment report, along with the certificate and product info, can be found on the SAEL. That is the Safety Automation Element List, or Equipment List. And this SAEL is also the website that you can go and find the most valid and up-to-date certificates. The safety manual is going to be something issued by the manufacturers. It's going to talk about those environmental limits or any restrictions, and that you ask your manufacturer for. Some manufacturers ship it in the box with the product. Some manufacturers have it posted on their website. Some just say, call us, we'll send it to you. But the safety manual has a lot of very important information for you, so always get that as well. Next, let's look at some examples. How to interpret the certificates. What did we talk about? Well, here's my first example. Let me see if I can get a laser pointer. So what did we talk about? Well, first we talked about that ANSI logo. As you can see, this looks a little different than what we originally just looked at, but that's just because this is a little bit older of a template. This one was recertified or certified in January, so it's not very old. It's going to have a surveillance audit due in the year 2020. So you can see this is a SIL3 capable device. We have the product name and the company, what it was assessed to. You have, see, your systematic capability is SIL3 capable. Your random capability, it talks about type A and route 2H. Those are the pieces of information you take to the standard and use the tables and the equations in the standard for that. It talks about its safety function and says for any application restrictions, look at the safety manual. You're going to have two assessors. Both people signed off for it, and that's why the certificate was made. On the back here, it reiterates the systematic and random capabilities because those are so important. It lists the failure rates per different failure modes. This was analyzed for both clean service and severe service, with and without partial valve stroke testing. And you have your safe detected, safe undetected, dangerous detected, and dangerous undetected failure rates that you can use in your equations. At the bottom here, you have your assessment report, name and number, and the safety manual number. The next certificate we're going to look at This is the newer the newer template. That's why this. So between January and May, we had a new revision of the certificate itself. Once again, you're going to have a safe or surveillance audit due in 2020. Here we have, let's say, what the systematic capability. This is a SIL3 capable device. You have the product name and the manufacturer, along with what it was analyzed for the requirements of. Here you have the systematic capability and the random capability, along with, it was a type B, and it was assessed per route 2H. Down here, you're going to have your safety function and your application restrictions. Once again, it says consult the safety manual. Here we had two separate certifiers say, yes, we agree that this is a SIL3 capable device. On the back of the certificate, it reiterated the systematic and the random capabilities, and it lists different failure rates per the different device configurations for this. It lists them then safe detected, safe undetected, dangerous detected, and dangerous undetected failures. Finally, at the bottom, you can see that there is an assessment report and a safety manual. Then one more example. This is, once again, ANSI certified. You have your when it was valid until, so this one's going to be coming up on recertification soon. You can see when it was assessed and see that this is a SIL3 capable device. This is the product name and the company, along with what requirements of what standard it was analyzed for. Your systematic and random capabilities, your safety function, and application restrictions. It says see the safety manual. Two of our fabulous engineers signed off on this. Let's go look at the back. Once again, it reiterates that systematic and random capabilities because they're so important. But this is new. So this is saying for those, there's so many different configurations on this product. And it was analyzed not only low demand for probability of failure on demand, but also PFH, so high demand. So there's failure rates for high demand. There's failure rates for low demand. There's so many different ways that the device was configured that it didn't fit on the certificate. So what you can do is they say, call us. This is the document. Call us. You can have the failure report. You can use Excellentia and do the calculations that, because this is already in Excellentia. You can get just the failure rates from the manufacturer itself. That doesn't happen often, but every once in a while you can find that. So don't be alarmed. This is definitely a valid certificate. So don't be concerned on that. You then have your assessment report and your safety manual. So how do you know if a certificate is valid? Well, it's awesome being a worldwide recognized program that end users recognize. They know that we have this knowledge. They know that something analyzed with us is trustworthy. Manufacturers know it's not just a rubber stamp. It actually is meaningful for their customers. But because of wonderful success and wonderful things, there's some downsides. Well, not every product and not every manufacturer pass our certification. And because of that, we do find counterfeit certificates out on the market. So these are a few of the counterfeit certificates we have found, and some of these companies had no clue that these certificates are out there, actually. Some of these companies have other certificates with us. What we found out on one of these, a distributor wanted to make a sale, did some copying and pasting, scanned it back in. It's good to go, right? Well, how do you know if it's a counterfeit? How do you know what's going on? Well, you simply go on that SAEL. Just as we said, we determine that authenticity. Go on exida.com novice.com, SAEL, they have the most up-to-date certificates on the market. So if a product passes certification, you're going to have both the certificate and the assessment report on the SAEL website. A lot of end users find the SAEL so great because they can search by device type. Say they want a final element, a ball valve. It will bring up a list of all of the certified ball valves. Then you can click on each one for more information. You can view their certificate on the back, see their failure rates, and get more information about that product before you can decide if you want to buy that product or not. So now that we know all of the tons of information on the certificate, well, what does this mean for compliance? What does this mean for you? How do you take this certificate and what do you do with that information? Well, the IEC 61508 and 511 standards say if you have to meet our standards, to be in compliance with our requirements, you not only have to consider one or two things, you need to consider these 3 barriers. And only if you consider all 3 and pass all 3 are you going to be in complete compliance of the standard. So if you do 2 of these perfectly, but are not even thinking about one, you're not in compliance with the IEC 61508 and 511. So how does this match up with the certificate? Well, remember that box? Well, the first thing is that systematic capability. That systematic capability is that SIL capability, that gray circle. Then underneath it talks about architectural constraints and PFD average numbers. Once again, we talked about why it's important not to publish just that PFD average, how misleading that can be. But that random capability is going to give you clues on how to find your architectural constraints and your PFD average. You're going to see how it was analyzed per route 1H or if it was analyzed per route 2H. You can use the tables then to find what SIL level you're trying to be, to what hardware fault tolerance you need, or what redundancy you're going to need to build into your system. Also, it talks about the probability of failure, that PFD average, that big long equation with 9 different variables. Well, it gives you your failure rates on the back of the certificate to use in your PFD average numbers. It also, what tables you use for low demand or high demand, and if it's a type A or type B device. So this is how you use these products in your system matter. So you get all of these pieces of information from the certificate. That's why the certificates are so important. So right now I'm going to go ahead and take questions. And if you think of questions later on, please feel free to email me later. Also, we have training upcoming. So if you want more information, please feel free to look at our training schedule. We have some great trainers out there. And if you want more information, please, or if you think of any webinar topics that might be helpful, let us know and we'll try and put one together for you. So let me see what questions. I think I answered this already, but it talks about that assessment report, where to find it. The assessment report is a public document, and it is on the SAEL. You just simply, it's a free website. You go to exida.com. At the top is a little button. You hit SAEL, and no matter, you can do an advanced search if you know what product you already want to look at. You do a search, and you can figure out. You can download a copy of the certificate and download a copy of the assessment report there as well. And the assessment report, if you ask the manufacturer, they should be able to get you a copy of that as well. So whatever is easiest for you. But it has a lot of important information, so definitely ask for it. I think that that's a very wise decision. So thank you. That's all the questions for today. Thank you so much for joining us, and I hope you enjoyed today's webinar.